Let's talk about Pythagorean Theorem. So easy. So many people get scared off on Pythagorean Theorem, but it's actually super, super simple. Okay, so I'm going to give you kind of the bare bones main things to know. Okay, we can definitely go deeper than this, but I'm going to just try to give you the easy stuff. Okay, so first of all, Pythagorean Theorem can only be done, used with a right triangle. Okay, so let's think right triangle. There's our right angle. All right. Pythagorean Theorem basically is used for finding a missing dimension. Okay, so you got 1, 2, 3 dimensions. Okay, as long as we know 2 of those, we can use Pythagorean Theorem to find the third. Of course, there are other applications, but this is kind of the starting point for Pythagorean Theorem. Okay, so a couple of things to know. These 2 side lengths right here, the 2 sides that make up your right angle, these 2 sides have to be called the legs. Okay, so that's a leg, and this dimension's a leg. And they have to be called A and B. Doesn't matter which is which. You could call this side length A, or this side length A, or this side length B, or this side length B. It doesn't matter. They're interchangeable. They just have to be called A or B. I'll just fill them in however it feels good. Okay, so A and B. Side C, side length C, always has to be the longest side of the triangle. It has to be the side opposite the right angle, side length C. And it's called the hypotenuse. Okay, so we've got 2 legs and a hypotenuse. And here's what the Pythagorean Theorem says, okay? So as long as we have a right triangle, okay, and we have A, B, and C designated, here's what Pythagorean Theorem says. If we take side length A and square it and add it to side length B squared, that sum of the squares has to equal side length C squared. And that's what Pythagorean Theorem says. It's pretty simple, really. So if we know any 2 of these, we could always find the third missing dimension just by solving the equation and using some inverse operations, right? So let's try one. Let's try a famous one. Let's try a famous triangle here. Okay, so let's say we got a triangle that is 3 long, 4 long, question mark. We want to find the hypotenuse. Okay, so as long as we know that this is a right triangle, we can go ahead and use Pythagorean Theorem to find this missing side length. Okay, so let's take and let's establish A and B. Okay, so here's our 2 legs. So this could be called A, or that could be called A. It doesn't matter. Just you're always safer though to establish the naming system. Okay, so if you want to call this A, fine. That one's B. If you want to call this A, then that one's B. Let's just go ahead and identify it. Okay, so I'm just going to pick. I'm going to say that's side length A, that's B, which means the opposite, the right angle, right? This longest side is C. I like to use A, B, and C. Okay, so let's do that. So side length A squared, okay, plus side length B squared has got to equal side length C squared. All right, let's go ahead and work it out. So let's go ahead and do these operations first. We can square these. So 9 plus 16 equals C squared. Let's go ahead and combine these 2 like terms here. We can go ahead and take our 9 plus our 16 to get 25. So 25 equals C squared. And then finally, all right, we've got all of our like terms combined. We just need to get that C by itself. We need to undo squaring over here. Okay, so the opposite, the inverse operation of squaring is square rooting, right? If I square root that side, I got to square root that side. Square rooting something that's being squared cancels each other out, which leaves us with C by itself, which is our overall objective to solve an equation. And then the square root of 25 is actually plus or minus 5, but we're just talking about dimensionings here. So it's going to be, we'll just leave it at positive 5. So there we go. So that's a 3, 4, 5 triangle. And we solved it. We used Pythagorean Theorem to solve for that missing side length. So there you go. Pythagorean Theorem, there's the basics. We can go a lot deeper than that, but that's if you can kind of understand this concept, you can take it to new levels. So there you go. Hope that helps.